Welcome to day 6. Your homework is pages 24 to 29, whatever we don't finish in this video. We're going to review circles today. Let's go to our calendar packet, page 11, and let's also be taking our calculators out so you have them and are ready to go. And if you don't have a calculator, remember to ask the sub for one, and they can give you one from the drawer. So first thing from the circles unit is our area of a sector and arc length formulas. We have those given there. Usually for area of the sector we just put an A there, and for arc length we put an L there. The theta in the top left represents the central angle degree value. And then under area of the sector you had pi r squared, arc length you have 2 pi r. Pretty often they just have area of a sector on the Regents. There's pretty much one area of a sector question on every Regents. Rarely is there arc length. Then next, at the bottom of this slide, we've got our general center radius equation of a circle. We have an x part squared plus a y part squared equals the radius squared. So notice it's 64 because we squared the 8. And the other thing I want to point out, in the general formula there's a minus, so notice that each of the signs are changed. So if we had like -6, comma 5, and a radius of 3, that would be x plus 6 squared plus y minus 5 squared equals 9. Just some vocab. A secant line hits the circle twice, tangent line hits the circle once. When a radius meets a tangent, they form a right angle. Then our circle angle rules. The central angle is the same as the arc. See how they're both labeled x. The inscribed angle, when it is on the circle, is 1/2 of the arc. This next picture over on the next page in your calendar packets is really just like an inscribed angle. It's just saying that it's 1/2 the arc. In the one on the right, if you're an angle that's formed by crisscrossing inside, your angle is equal to 1/2 the arc it opens up to plus its vertical angles arc. And then the 3 scenarios we have where the angle is outside the circle, that angle is just equal to 1/2 the bigger arc minus the smaller arc, where the big arc is the second one, the further one away from the angle. Then going over to our formulas with segments. If you have chords crisscrossing, it's just part times part equals part times part. And then we have our either two secants or a secant and a tangent. It's outside times whole equals outside times whole. Remember on the tangent one over on the right, the one part PC there, the outside and the whole is just the same thing. And then lastly, if you have tangents coming from the same point, they are just equal. So hopefully that circle stuff is somewhat familiar to you because it's the last 2 units that we did during the year. We're going to move over to the Regents problems packet, packet page 24. We'll give you a minute to flip to there. All right, so these types of questions are very common on the Regents. These were the ones where we had to complete the square to find the center and the radius. So first off, over on the left, we want any x's and y's and the constants over on the right. So I'm going to subtract my 8x over, and I'll add the 6y over to the left as well. Now when I rewrite these, I'm going to strategically rewrite it so that the x stuff and the y stuff are grouped together. So we're going to have x squared minus 8x, and then I'm going to do plus a blank, plus y squared plus 6y, and then plus a blank, equals the 39 that's left over there plus 2 blanks. Now we're going to do the actual act of completing the square. When you complete the square, you do the b value divided by 2 squared. The b is in front of the plain old x or the plain old y. So for the x's, our b is going to be negative 8. We'll do negative 8 divided by 2 squared. Negative 8 divided by 2 is negative 4, and it's squared. Notice I'm putting this in parentheses. It's important if you're going to use your calculator to figure that out. It has to be written this way, and I strongly suggest showing this work because that negative 4 is going to come into play in a second. A negative times a negative is a positive, so we just get 16. So we'll add that in that first blank, and whatever you add to one side, you got to add to the other. Now we'll do it for the y's. The b value, which is in front of the plain old y, is just 6. So we'll have that divided by 2 squared. 6 divided by 2 is 3, so it's really just 3 squared. And we'll add on a 9 on both sides. So now we're going to put this in our center radius form. We're going to have an x part that's squared plus a y part that's squared equals some number. If we add up the right side, the 39, 16, and 9 give us 64. And then for the x part, remember it was negative 4 that we squared to get 16. So this is just x minus 4. And it was positive 3 that we squared to get 9. So this is y plus 3. Now for our center and our radius, the center is just the opposite signs of what we see in our equation. So the x part will be a positive 4, the y part will be a negative 3. So that allows us to rule out choices 1 and 3. And then the radius, in the equation, the radius is squared. So we would want to do the square root of it to figure out what the radius is. So our radius will just be equal to 8, and therefore we get choice 4. Now in a multiple choice version one of these, there is a test taking strategy you could use if you were totally stuck and didn't know how to do this. I would suggest knowing how to do this because it does come up as a free response. But if it's a multiple choice, we can just type this in a graphs page as a relation. So if I went over here to a graphs page, we'd have to put it in as a relation because y is not by itself. So we would just delete out the equal sign, go down to relation. We would type in x squared plus y squared equals is right under the control button. Then we had a positive 8x, we had minus 6y, and then we had a plus 39. So I just typed in the original equation that they had. Notice it graphs the circle for us. So it's pretty clear that the center is going to be somewhere down in quadrant 4. Quadrant 4 means we went right and down, so it's got to be a positive x and a negative y. So if we flip back here, positive x and negative y tells us it has to be choice 2 or 4, and then we're down to either radius 64 or radius 8. Well, if the radius is 64, you wouldn't even be able to see the circle on this page. So it's definitely got to be 8. Now, if you wanted to get even more complex, once you have this drawn, you could go to Menu, Analyze Graph, Analyze Conics, and you can just ask it what the center is. You just click on this, and notice it gives you the actual center of 4, negative 3. You also could go to that menu, Analyze Graph, Analyze Conics. Notice it says Radius. You could click on the circle, and let's see. See now how when I hover over, or I guess as I'm drawing around, it's got that radius of 8 there. Okay, so again, the way I got that, I did after graphing it, I did menu, analyze graph, analyze conics, and then you can select center and radius, and it'll actually tell you each of those things if you're unsure. Okay, so on page 24, going to the next one, we've got that EM is 8. We've got RM is 15. And we want to know what could the lengths of JM and TM be. Well, we know that from what we had in the green packet and during this unit, that our setup for this is just part times part equals part times part. So 15 times 8 is just going to be whatever Jm times Mt is. Well, that means 15 times 8, that's just going to give us 120. So all we're going to do is we're going to try out these four options for Jm and Tm and see if they give us 120. Well, if you do 12 times the 9.5, that's going to give us 114. So it can't be that one. If you do 14 times 8.5, that's going to give us 119. So it can't be that one. If you do 16 times 7.5, that's going to give us 120, so it's probably going to be that one. But I would just double check and do the last one. 18 times 6.5, that gives us 117. So therefore it's got to be choice 3. So that's just a different way rather than having you solve for the variable to see if you know your rule of part times part equals part times part. All right, circle O, reminder, a circle is named by its center. So if we've got circle O, that means O must be our center. We have two secants are drawn to an external point P. Secants hit the circle in two spots. So there's our point P that is outside the circle. Notice the order of the points A, B, P. B has to be between A and P, so that means A would be here, B would be there, and then P. And likewise, we have C, D, and then P. AC they said was 72 degrees. BD they said was 34 degrees for our arcs. And we want to find P, so I'm going to pick a variable not in our problem. Yeah, I'll call that X. We saw in the green packet when we went through it, when you have an angle outside of the circle, that angle is equal to 1/2 the big arc minus the little arc. So in other words, the arc that's further away minus the arc which is closer. And if we just type this in, this is going to give us 19 degrees for X. Double check um, that X is what you wanted. We called X angle P, and angle P is what we wanted. All right, moving on to question 5. We have circle O, that means O's our center. K, A, T, I, and E are on the circle. Our two triangles are drawn. We've got that arc KE is congruent to arc EI. EKA, so this angle here, is congruent to EIT, so I is the middle letter, so that angle there. And we want to know which of these is always true. Well, one thing we want to know is that angle A and angle T are inscribed, and they're opening up to congruent arcs. Inscribed angles are always half their arc, so whatever KE the arc and EI the arc are, A and T would be half those degree values. So we know that these two are congruent. So we can definitely rule out they're neither congruent nor similar because right now we have angle angle, and angle angle similarity postulate gives us similar triangles. We could only get a right triangle if one of our inscribed angles was opening up to a semicircle, and we would need one of our chords to go through the center, making it a diameter. So we can't possibly get that it's a right triangle. To be congruent, we would need to be able to get another side. So to get another side, we're looking here for either angle angle side or angle side angle. Now something that we saw very briefly in this unit is that if you have congruent arcs, the chords that connect them must also be congruent as well. So we have arc KE and arc EI marked congruent. We can also get chord or segment KE and segment EI to be congruent. Well, now we have angle, angle, side congruent to angle, angle, side. So that means that we can get these triangles to be congruent. All right, so moving on to question 20. So we have two ways that we could do this. We could type each of these equations in as a relation, see which one has a diameter of 1 or a center of 1 comma 4, and if diameter is 10, we'd be looking at radius equals 5. Or we could do these with the completing the square way. So let's just kind of walk through the completing the square way. So we've already got them basically in the form that we want. Now, if we want a center of 1, 4, eventually we're going to want x minus 1 squared plus y minus 4 squared. And if we want a radius of 5, 5 squared gives us 25. So this is the equation we eventually want. Well, for the negative 2 for the x, we would do negative 2 over 2 squared, which gives us negative 1 squared. So we'd add 1 to both sides. Because negative 1 is being squared, eventually that will be x minus 1 squared. So it looks like this is pretty good so far. For the y's, we'll do negative 8 divided by 2 squared, so that'll give us negative 4 squared. So we're really adding 16 on both sides. Because negative 4 got squared, this is y minus 4 all squared. So that's looking good. And then 8 and 1 is 9, 9 and 16 is 25, so it looks like this one's going to give us what we want. Now that would have been annoying if we had to go through 4 choices and do that, but it could be done. And again, also you could graph it, do your relation, and then you could always do menu, analyze graph, analyze conics, and select center, and then select radius, and have it tell you what the center and radius is for them. So you do have that as an advantage to use the calculator if it is a multiple choice. All right, going on to question 13, we've got a diameter. Remember, that's always nice to note because it splits into two arcs that are 180 each. We've got some radii. So remember, we always wanted to put our little tick marks on all the radii. We know all radii are congruent, so notice now we have an isosceles triangle there. So that guarantees that these base angles are going to be the same as well. And we got a chord that's drawn. So angle TRE is 15 degrees. So R is the middle letter, so that's really this one right here, meaning this one has to be 15 as well. Because those are 15, we know the central angle is 180 minus each of those, so we'll end up getting 150 for the central angle. And they told us BE is 9, so that's just our radius is 9. So any of these radii actually would be 9. And then we want the area of the sector of EBR. So area of a sector is like the area of a slice of pie or a slice of pizza. So we want the area of that sector. From the green packet, we saw our formula is theta over 360, where theta is the central angle, equals the area of the sector over pi r squared. So we did have to make some connections to get to that 150 for the theta. We're looking for the area of the sector, and we'd have pi times 9 squared. So if we cross multiply, we're going to get 360a. And then we'll have 150 times 81 really, because it was 9 squared. So we have 150 pi. And we'll divide by 360 on both sides to get a by itself. Now note all the answers are in terms of pi, so we're just going to divide those other numbers. And notice it is in decimal form, so it's probably not going to come out nice. So when I put it in my calculator, instead of just hitting enter, I'm going to either put the decimal point after the 360 or control enter. and that gives me 3 or 33.75 and then pi. So that ends up giving us choice 3. All right, we're going to do one last problem in this video. So number 20, we have a center that is 2, -4. Well, we know in our equation that shows up as the opposite sign. So we're going to have x with a -2. We'll have a y with a +4 being squared, and that's going to equal something. Well, already we can rule out choices 3 and 4. This one is showing a radius of 2. This one is showing a radius of 4 because it's really equal to the radius squared. So what we're going to do is we're going to do a quick plot of this. So we've got a center of 2, -4. So 2 to the right and 4 down. And the line x equals -2 is a vertical line where x is always equal to -2. And if you didn't know that, you could graph as a relation x equals -2. And what we need is a circle that's tangent to that line. Well, tangent, remember, just hits in one spot. So there's roughly what tangent to that would look like. And we just need to decide, does that radius look more like 2 or does it look more like 4? Well, it's 2 to get to the y-axis, 2 more to get to the red line. So therefore, we're having a radius of 4. So the radius squared would give us 16. So then we have choice 2. The rest of the period, you can keep working through the remaining problems for this day. So 24 to 29, so you got the rest of those to work through, and have a good rest of your day.